Thank you for coming to my talk, ladies, gentlemen, sentients named Bob. Just quick curiosity, other than the obvious, how many people named Bob are actually in here?
Yay, Bob.
One? All right.
Oh, not really.
Not really? Oh, okay.
Praise Bob.
No, so really, okay. So the question then, I guess, is if all you read as far as the title of the talk, you're probably wondering who Bob is.
No, I was wondering
Not
about the Savannah College of Art and Design.
So, yeah, Bob, is he just some fictional character I made up? Maybe some kind of abstract concept that we're supposed to identify with? That some metaphorical representation of a person that you can associate with and make the talk more accessible? No, that's true. No, Bob's a real guy. He's sitting right back there. He's just a friend of mine who makes a living as a programmer. He has zero artistic talent. And he's been begging me to do a talk on OpenSCAD because he's too lazy to teach it to himself. So, for those of you who have never seen OpenSCAD before, that's what the application looks like. To plagiarize Wikipedia, OpenSCAD is a free software application for creating solid 3D CAD objects. Computer-aided design. It's a script-only based modeler that uses its own descriptive language. Any OpenSCAD script specifies geometric primitives such as spheres, boxes, and cylinders, and defines how they are modified to combine and render a 3D model. But before we get in too deep, I want to make one other quick disclaimer. First of all, I'm not a programmer, even though this is a talk kind of about a programming language. I don't code for a living. I'll dabble here and there. But I guarantee if you see me in Bob's OpenGL talk tomorrow, you're just going to see a glazed, confused look on my face. I'm also not any kind of like engineer, mechanical, or structural. I don't know anything about metallurgy or material sciences or building codes or anything else that normally a professional would use CAD for. So you might be curious, like, who am I and why should I care about what I have to say? Well, my name's Joe. By day, I'm an information security analyst for Washington University of St. Louis, Missouri. I did spend a semester as an art major about 20 years ago. I'm also founding member and current president of Arch Reactor, the St. Louis Hackerspace. I do have 2 3D printers at home. I have my eye on a third that I'm going to purchase. Again, still none of that really means I know what I'm talking about, but Freaknik's letting me talk anyway. And if you have a problem with that, complain to Bob. Again, this was all his idea. So moving on. Despite my own shortcomings and lack of proper training, I have successfully designed a few things in OpenSCAD. First being, this is my lock collection at work. I made all those little hangers. Each one's custom for the specific diameter of the latch. That's a very simple example. But I just didn't want them lying in a box. I wanted them all displayed so it'll confuse my coworkers as to why I have those. I've also made this is just a very simple Raspberry Pi camera mount that attaches to a little robot chassis I have. At one point I broke the knob off my favorite fan, and for a while I used pliers like everybody else. I got really sick of that and remembered, oh yeah, I did spend like $1,000 to buy this 3D printer at home. I should probably like get some use out of it. So I made this. What's that?
Your fan's looking pretty rough.
It is, but it's my favorite fan. I don't want to let go of it. It really works. It works really well. But it's but that model actually only took about 30 minutes to design, and another 10 minutes to print. All in all, that's quicker than a trip to the hardware store to find the right part. In fact, that worked so perfectly. I was so pleased with myself. I ran to my electronics bin, pulled out all my potentiometers, and printed knobs for them all. Like I was going like really crazy with it. Other things I've done, protective caps for like gadgets and stuff. I don't know if you've seen this before. This is a little USB device called a Bash Bunny. It's for pen testing. When I ordered it, I was really frustrated that like it didn't come with a cap. It's supposed to be like look like a USB key. Well, there was no cap, so I made one of my own. And that's what that is. By far the most complicated thing I've ever built is this guy. That's my creepy robot head. He has teeth and he can actually see you and he smiles and everything. You might be asking why I'm not presenting on this, because it's much more awesome than this talk here on OpenSCAD. Well, Bob wanted me to do a talk on OpenSCAD, not to talk on my robot. He already knows how my robot works, especially since he helped me design all the software for it. And it's, to be perfectly honest, it's also like mid-upgrade. I'm redesigning a bunch of stuff or rewriting the code. Also, the last convention I brought it to, I let the magic smoke out of several of the servos. So it's a little in disrepair at the moment. The point is, though, I have a little experience with OpenSCAD at this point. I've successfully designed a few things that I printed and didn't immediately fall apart. But why bother using OpenSCAD? Well, there's the reusability aspect. It's always easier to repurpose something than to start from scratch when you're dealing with code. There's you have the ability to make parametric models, which makes everything, you can reuse stuff like the little dials that I made. You can, with just a few tweaks of the code, because everything's saved in a plain text file, you can use Git for version control. OpenSCAD was actually designed from the ground up to be, for 3D printing. Any models you generate in there will be a sealed model, watertight as they call it, and there's no chance of like forgetting a polygon somewhere, and then so when you try to like slice it on your 3D printer, the whole thing falls apart and doesn't work. OpenSCAD is designed to prevent that. It's also, I call it Thingiverse compatible, and basically what that means, if you've ever been on Thingiverse and you see, Thingiverse, for those who don't know, is just a giant database. It's kind of like GitHub, but for 3D objects. People post their designs up there for people to browse and download and print themselves. Thingiverse has a customizer web application where if you put a few, format your OpenSCAD code the right way and put in a few, tell it what variables to look at, you can then upload the code, and anybody can download your code or download your object, and on the website tweak some of the measurements, make it customizable for them without having to know squat about CADing in general. So that's a really neat function. But that's all what it says on the website. So why do I really use OpenSCAD? Well, despite my single semester as an art major 20 years ago, I've always struggled with 3D modeling programs. Photoshop, I was no problem, but when it came to like 3D modeling, I couldn't grasp my head around it. This is like the first application I was able to actually be productive in. Once I find something I can get to work, I stick with it. Same reason I'm a Vim user, to be perfectly honest with you. It's the one I got to work first. It also works with, if any of you saw my talk with Bob last year on going commando, working from the command line, this fits really well into my CLI workflow because it's all text. I can even render stuff from the command line using OpenSCAD. I like it for that. But most importantly, why use this? Well, Bob thinks it's a really cool idea. So even though he doesn't know how to use it yet, hopefully he'll stop pestering me after this. Few notes on the OpenSCAD language. Just like I said, I made this talk with Bob in mind. I previously mentioned Bob makes his living as a programmer. So this isn't going to be kind of your basic, like an introductory to OpenSCAD style of talk. There's no going to be any hello world. I'm assuming everyone in here knows how to teach themselves a new programming language. For the most part, this is just another kind of scripting language or coding language. Most of your standard best practices in that regard apply. So instead, I'm going to more focus on how I use OpenSCAD, highlight a few things in my workflow, and point out a few of the nuances that I found with OpenSCAD that might trip you up when you're trying to use it. For those of you that are programmers out there, a couple of errata things to take note of. Excuse me. Modules or functions. Terminology change. Instead of creating a bunch of functions that do stuff and output results, you call them modules. That's not to be confused that there are also actual module or functions still in OpenSCAD. The difference being is anything you do in a module has the immediate side effect of it's generating a 3D object, whereas functions are kind of like the math kind. They're strictly functional and that's it. Variables are a little weird. Variables are tend to behave more like constants. They you don't change I mean, you can change them, but all the math happens before it renders your object. So whatever the final value of a variable is going to be what it is throughout the entire the entire model you design. So it's, even though they're called variables, it's really best to think of them as constants. That does have the added benefit of you can really get away with like just putting them all at the top and keeping them all global. Makes things easier for you. Also makes things a lot easier when you're tweaking stuff or designing a parametric object down the road. Vectors are also called arrays, or arrays are called vectors, which is another weird terminology different. When you're dealing with geometry, I suppose that makes a little more sense. They behave pretty much the same. It's just a block of numbers like you do with an array or a matrix. There are if and then statements. They don't get used a whole lot because if you think about it, when you're designing something, you kind of have an idea of what the end result's going to be. So there aren't a lot of questions that generally need answering. Nobody's going to build a house and have conditionals to tell you whether you need 4 walls and a ceiling. That's just kind of assumed. You can nest things all you want. I have no problems with calling functions or modules from within modules, from with other modules. I don't care how messy it is or how inappropriate it should be. We're not building applications here. We're just drawing shapes. There's no interface that you're going to pass bad data through and break the application. The end result's just something neat, just a neat design. So a few things on how I work in OpenSCAD. First thing you want to do is gather all your measurements. By that I mean if you're integrating something, usually if you're designing something, it's probably going to have either motors or you're going to screw some pieces together or you're going to put a PCB in there. Get the measurements for all of that. Figure out any footprints. I usually reference a data sheet if it's available. If not, I'll break out the ruler and caliper, start doing it myself. Yeah, as long as you're within like a millimeter or 2, that's usually good enough. Doesn't have to be super accurate, you know, because in the end of the day, I'm usually 3D printing stuff. There's some slop in there already. Then next thing you want to do is write everything down. Take all your measurements, sketch out what the measurements are, figure them all out. Once you've got all that, then you can go ahead and start sketching out your design. I mean, you don't have to be a great artist. You don't all have to be great artists with like a single semester of art college like I am, but just a rough sketch so you have an idea of how everything's going to fit together, where the existing hardware is going to fit. And once you've got that, you've got all your prep work done, you can go ahead and create a new project. I've actually built myself a little script that helps me out. It creates a new directory for me for my project, copies over the directory, or copies over the template file and any libraries that I'm using. I even have it like initializing a Git repo for me so I can save everything, does the initial commit. Yeah, is that working? Oh, wrong button. That's just the script I use right there, no big deal. So go ahead, open that project, then you're going to go start entering in all those variables that you just wrote down. You see, I just got like a section here, so if I had a bunch of servo dimensions I was going to put in, I'd start with all of that, put in the hardware values first. Then I'd move on to anything additional, like the bracket that's going to contain the servo or the motor or anything like that. I would base around those existing measurements. So if I knew I was going to have, I knew it had to be at least the size of the servo. If I had to screw something in, I know I'm going to need the wall thick enough to be the diameter of the screw, so I would take that into account. So the actual thickness of the object and dimensions of the object are going to be heavily based on what existing hardware I'm using. The added benefit to that is if I can't get that same motor or same servo somewhere, or I run out of those screws and I got to use something different, I can easily tweak the model. The whole design is going to reaccommodate itself so I can fit in the new piece. There's a couple other special variables there at the bottom. You can see I've got a one that says print gap. I use that for taking into account the variations in a printer. Explain that a little more. At the very bottom, I've got this one standard FN. The $sign FN is a special variable in OpenSCAD that you might want to play with. It basically says how many polygons and you need to make an object. So if I have If I only select 5 and I make a cylinder, it's going to be a very blocky looking cylinder. If I use 50, it's going to be a lot more smooth. Of course, there's a trade-off on like how long it takes to render and everything like that, but there'll be times where you'll care a lot more than other times. Like I said, define all your variables. Take into account tolerances of the material, like how big the screw is going to be. Your printer's not going to be perfect. Not everything's going to be down to like the 0.5 millimeter or whatever. That's where my print gap value comes in. It pretty much takes into account the the diameter of the nozzle I'm using, and I'll only use that where it's appropriate, such as like the orientation of your print's going to matter. If you're printing something horizontal, or let's say I have a recessed screw hole in the object. If it's horizontal, it's actually on a 3D printer, it's going to be a little more accurate than if I was putting that vertically, because the diameter of the nozzle is actually going to come into play there. So understanding your printer and things like that comes into play a lot. Another thing to remember is be mindful of curves when you're trying to smooth out corners. Eventually you're going to want to start, you're not going to want sharp corners on everything. Having nice little curves makes things look nicer. And when you have something, you have a little gadget in your pocket that you printed, you're going to not want to jab yourself in the leg with it, with a sharp corner. So when you add a little curve, you end up actually adding the radius of that curve to the object. So that's something you need to keep in mind as you get deeper into this. At that point, you're going to go ahead and start building shapes. Like everything you want to do, anytime you're building a block or an object, you're going to go ahead and put that in its own module, break it out. That's going to, one, keep everything readable for you as you're going through your code, and if you find you've written something useful, it's going to make it easier just to copy and paste it and reuse that code. If you're doing it right, it really ends up being the difference of like if you're sculpting with clay or marble versus using Legos and building blocks. If you got all modules and you can just start plugging stuff together and build stuff really rapidly. Something a little more trickier is if you have to build something asymmetrical. Something like a case for something like oddly shaped electronics, PCB boards or something. The example we're going to use, the bash bunny cap I made before. One of the problems I had with that was that it's got this weird roundish shape. There wasn't a very easy way to figure out what that curve was or anything like that, and they didn't publish a design for the case online or anything when I bought it, so I had to figure out what that was. Well, like everything, I always start with a sketch, but more importantly, if you just look in the bottom left corner, I guess from your perspective, there's a little sketch. I just plopped the bash bunny down and I literally just traced it. And then I scanned this in, went ahead and opened it up in like Inkscape. Any other vector-based graphic program will work as long as you can save it as SVG. Cleaned it up a little bit, got myself a nice little footprint. Once I've got that, I can take that SVG and I can actually import it into OpenSCAD. And I can actually take that 2D object and do what's called a linear extrude, pull it out, give myself basically the rough same shape, except in 3D. It's very much like, if anybody remembers the old Play-Doh Fun Factory, you've got the thing full of shapes, you push down and squeezes out the Play-Doh in the shape you're looking for. It's just a digital version of that function. And now that's perfectly serviceable shape. That could have worked for the cap if I needed to, but again, like it's got those sharp corners. I don't want to be jabbing myself in the leg, so I'm going to give it a little curve at the top. That's what I did next. You'll use the Hall and Minowski functions to do that, and we'll dive deeper into that. Then I got to put a little cutout on the bottom, but the important was how we had to shape it. Now, at this point, I've got a fully functional cap. I can put there's a gap where I can put in the USB plug. It'll cover, keep the dust out, but the thing's called the bash bunny, so I really kind of wanted to have rabbit ears, just because I thought it was funny. I was very strong in that opinion. But and having that, I designed it in such that having those rabbit ears, yeah, sometimes I may want that, sometimes I may not, depending on like if I need it to be looking professional or not. So the way I designed it is there's just this one variable, enable ears equals true, and that'll turn off ears whether or not and render a new object for me. So that's like one way you can do a parametric object, which if you don't know what it is, I've said it before, parametric objects, just really the ultimate way to reuse code. Just have a very kind of generic model. You can tweak things and customize things very rapidly. If you look at Thingiverse, Thingiverse has whole collections of parametric objects from everything from like gears, boxes, jewelry boxes, various mounts for things. Very fascinating. And unfortunately, it's so diverse that Rule 34 also applies in some cases. And on that note, at risk of losing my PG rating, I did find my new band name. This is out there. I won't stay too long on that. But right, it's a Christmas tree, right? That's all it is. But something a little more versatile for a parametric object. If you remember the fan dial on that I made for my favorite fan that keeps me cool at night. This model is actually a lot more versatile than it may first seem. I've got a lot of functions on it. I can put labels on it, add a little texture on the outside. That's what the model actually looks like in OpenSCAD. And I can actually adjust all these different things. How the diameter of the model, if I need a bigger knob versus something smaller that's going to go on a little dashboard or something. And whether or not it's got the little notch on the bottom, the handle, the label, all that stuff. And all that's just by adding variables into the code. All these here, if you look at it just real quick, there's a variable for everything on that previous list. And tweaking any one of these things will adjust the overall dial. But let's look at how that kind of fits together all together. This function here is from the model, is kind of the central function. It's puts everything together. If I call dial knob, it just goes through and calls a bunch of other functions. Like I said, break everything out into a module. That makes this a whole lot more readable. So I can see that I'm creating kind of the base shape, adding knurling if I need to, whether or not I need the grip, drilling the hole at the bottom, label text. It makes it very clear of how that works. And then breaking out into all those functions. If we just go down the list of how each of those works, we start with the basic shape, the knob base. It's not overly complicated. The heart of it's just basically a regularly shaped cylinder with a different diameter at the bottom as there is at the top. The sphere and the Minowski function there is what gives it the little bevel shaped. Minowski is a function that adds the geometric shape of the sphere to the cylinder, which is why you get a slightly larger shape, because it's adding that radius to the length, the dimensions of the overall objects, which is exactly why you need to keep track of those bevel edges. Otherwise, you end up printing something and then, hey, it doesn't fit. It's like way too big. But with that function, we get this kind of basic shape there. It's kind of marshmallowy shape, but yeah, overall, it's just kind of like an oddly shaped cylinder. And then moving on, so let's put that little grip on it. I'd call the module grip. It's not very different from the other function. Again, I've got a Minowski function just to kind of smooth things out. But there's the hull function here, and you'll see I've got two cylinders. What the hull function does is it'll take, using the shapes that you have defined within that function, it'll use those as kind of the border of the shape and fill in everything in between. So if you need to quickly design kind of like an irregular shape, it's a very quick and easy way to do it. And so yeah, I've just put, here's two cylinders, fill in everything in between. You get that little handle on the end of it. Again, I've got the sphere with the Minowski just to kind of bevel the edges off. And then there's the shape I get. I get that nice, little grip there that makes it easy to turn my fan on and off at night. Next up, well, I need to attach to my fan. I still need a hole. So I don't know how else am I going to get on the switch. Well, that's just easy. I got a drill hole function. Basically, it's just, hey, here's a cylinder of the diameter of the post that you're going to put it on. I do have like an if statement in here, and all that does really is change the height of whether or not I have the grip. I drill that stem a little deeper, that hole a little deeper if I've got the grip on top or not. But that's basically how that works. There's going back to the dial knob, the reason if you saw, I'm just calling cylinders. Why am I not just adding it? I've got this difference statement in here. A difference statement you'll use quite a bit. The difference statement basically removes any shapes that you define from the first object you define. So the first thing I define is the knob base. And everything after that is going to get cut out of the knob base. So I've got the knob, and so later on when I call the drill hole, it's going to tell it, all right, that cylinder you just made, take that volume out of the overall shape. And that's what we get. We got a nice little hole in the bottom. Now on my fan, you may have seen this if you've ever broken stuff off of like kitchen equipment. A lot of times you have those key notches that make sure you've got the switch pointed in the right way. Well, my fan needed that, so I went ahead and wrote a little function in that. Sometimes I've seen them switches with one, sometimes there's two. I've never seen more than two, but I made it so that I got this nice little function. I can just tell it how many notches I need at the top. It'll figure out whether if it needs them, it'll go ahead and run this function and actually do the math to figure out where along the 360 degrees it needs to place them. And so I only needed one for the fan, so it just adds the little flat bit there so it'll fit nicely. If I needed two, it figures it out automatically. Next, let's just do some details on it. If I wanted to use it for something else, I can do a text label. When you generate text, it's kind of like with importing the SVG. Text ends up being a 2D shape, which you then have to extrude out, like we did with the Bash Bunny. So you can see I've got the linear extrude function there. I'm defining how tall it needs to be, and then just telling it what it needs to say. Another note, that's what it ends up looking like, just default label, and of course I can make that say whatever. A couple other notes on text. It does come with the Liberation font set, which is an open source font set that Red Hat and I think Oracle and a few other people have contributed to, and that's included with OpenSCAD. It will also recognize any other TrueType or OpenType fonts that you have registered with your OS. So if there's something really specific you want to use, you should be able to use it just fine, and you just change that. But I thought maybe one day I may want to add some texture to it, a little knurling, so that for a grip, if it needed to make a volume knob for something or anything like that. So I went ahead and made another function for that, even though I wasn't using it on the fan. And basically, it's very similar to the notch function we were looking at earlier. It's the same kind of math. I'm telling it where to put this object, a number of times around to 360 degrees. And in this case, I'm doing little cylinders, and it just cuts out little notches along the outer rim, and where they go is all defined by the diameter of the SCAD, or the overall shape and everything. But a couple other notes on parametric objects. You'll really learn to hate how much your high school geometry and trigonometry works. There are many times where I know I should go look up some function I learned in high school and was just stubborn and was convinced I'd figure it out, and 3 hours later I finally break down and fine, I'll look it up. Oh, SOHCAHTOA, that's right. And then it just works like that, and I'm really mad about it because I guess I've got pride issues or something. But when you do it right, if you do everything right when you're making a parametric object, like I said, if you base it all around the existing hardware that you're using, the motors and screws and everything else in the model should just accommodate itself. So if you have to ever change anything, it'll just automatically adjust. I did that quite a bit on the robot head you saw earlier. Even aesthetic things like the how big the teeth were on the object were just really arbitrarily designed on how big the screw was. Yes?
Does it let you render an image of what it'll look like before you try to actually physically produce the object?
So the question was, does OpenSCAD let you render what the object will look like before you actually print the object? So there's no printing function in OpenSCAD. You export it as an STL file, which is kind of the standard 3D model file that other people use for 3D printing that you put into a slice or whatever. But yeah, all these, go back. This is a live, well, this is a screen capture, but this is what I see in OpenSCAD when I'm writing code. Every time I make a change, it live updates kind of a rough outline on that. And then you can hit render and get a more proper, what the final object will be. So sometimes you'll see like kind of artifacts that once you render won't be there. But yes, is the short answer to your question. Moving on to like reusing code. So in that last object, I used pretty much the same kind of function for doing the knurling and figuring out where the little key notches went. So clearly that, I used that twice in one function. That seems that putting objects along a 360-degree circumference seems to be a pretty useful thing. So I ended up copying that out, reusing that code, putting in a little library. I highly recommend starting yourself a little library of like all little useful tricks that you figured out, and you can import them and use them in later objects. It's one of the reasons I've been stressing so heavily to make sure you put everything in a module. That way you can just copy and paste stuff later and not have to worry about like restructuring it when you actually do it. If you really want to get fancy with it, learn the children function. You can look that up on the wiki. Basically, instead of doing something specific like a cylinder, you can say, all right, this function would whatever object follows this function, the child line of this function will apply to that. It will apply the function to that instead. It's very useful. There's plenty of other. Here's a quick peek of my personal library. I've got several things in there. One being, there's a make ring of function. That's the one we were just talking about. I did go ahead and pull that out. So if I needed like just a ring of anything, it'll go ahead and make that for me. A couple other useful ones that I found, especially when I was making the robot head. Generally, when you're building stuff, especially complicated stuff, there's going to be a lot of parts. You got to fit them together somehow. Usually that means screws. Well, I'd like to kind of recess those screw holes so that they're flush and not sticking out and keep everything looking nice. Made a function for that. Basically, this gives me a recessed screw hole so I can sink screws flush in the model if that wasn't obvious. Basically, all I need to do with this is tell it how long, how deep, and how where I need to screw it, and it does it. Another similar one, usually you just don't ever have just one screw in an object. So I came up with this one too, screw hole pattern. I'll give it an array of X, Y, Z coordinates, and then it'll go ahead and drill a bunch of screws for me in a pattern, if I need all four corners or whatever. Granted, that's just a simple for loop if you look at it, but I don't have to type a new for loop every time I need to do it, and this saves me a lot of time in the end. A couple other libraries that are out there. There's a bunch out there. OpenSCAD comes with one called the MCAD library, which is a collection of standard libraries with standard measurements for screws and things like that. A lot of helpers for making mounts for common stepper motors and servos and that sort of thing. I haven't made a whole lot of use out of it yet. I just haven't had the time because I'm usually in a hurry when I like to build stuff like a week before like a convention. And so I don't have time to learn a lot of new things. It's how I work. It's a bad habit. But another one I use quite a bit is fillets.scad. It's out there. Basically, just anytime you're making anytime you have like an inner corner, that's very useful for smoothing that out. In addition to having that inner corner look nicer, it also strengthens the print overall. You'll find if you do a lot of 3D printing, if something's going to break, where that corner is, that's going to be the first thing to break. So I tend to use that a whole lot. I'm sure a lot of people use Raspberry Pis, Arduinos. There's lots of people who have done lots of different libraries for all those sort of things. Plus any other kind of thing you may think of. Check to see if somebody else has already done it. No need to redo work that somebody's already done for you. But to see how some of these libraries work, this is the camera mount that you saw earlier for that Raspberry Pi camera. It's not a very impressive design, but I used that screw hole pattern function quite a bit. First thing I did, like I said, I always reference like a data sheet or take my measurements. I pulled those measurements right off the data sheet for the Raspberry Pi camera mount. Like I said, threw them in a vector, which I didn't even bother like adding up, like, all right, how far over? I was like, it says it's, 21 in from this spot that's 2 in. It's a computer, I'll let it do the math for me. So just plopped all those figures in, went ahead and said, all right, here's where I need screws. Go ahead and drill them, and it went ahead and did it. And that's where the Pi went. I went ahead and did the same thing again for the mounting plate, where it actually connects to the robot chassis. It doesn't have to be just screws either, even though I called it like the screw pattern thing. I used it again for those 2 fillets that you saw that provide support in the back. Granted, it wouldn't have been a lot of extra lines to type, but on my calculations, I cut my code down to about 1/4, just by not having to retype stuff and using just a simple little function like that. A couple other miscellaneous notes when doing stuff in OpenSCAD that didn't really fit into like the other areas. I've got, you may not think you need to move an object from where you generated it at first. You're going to be wrong. Always put like a translate and a rotate function before every object you create. When you have to go back, you're going to be glad you saved yourself those 20 keystrokes or whatever that you needed to actually tweak your object later on. Translate, the translate function, always use a vector whenever possible. Put that up with the rest of your variables. That way you can tweak things instead of having to hunt through all your code and find out where the proper line is that you gotta tweak stuff. There's a command called union. Union is pretty much useless. I almost never use it. I've used it on a few rare occasions. If you're using a union function, you're probably not breaking it out into a module like you should be. So take a step back, look, and see if you can do it a different way. Let's see, I highly recommend experimenting, learn Newton tricks. Always try to reduce the number of lines that your OpenSCAD code is. I'd say stop just short of it no longer being reusable. I also highly recommend browsing Thingiverse. Avoid the adults only area, but the rest of it you'll find libraries that you'll find useful. Even if the library does what you do, I still recommend opening up, taking a look through the code, seeing how it does. You'll learn a lot of interesting tricks you didn't think of before. I needed a hexagonal grid function for a project. I basically make like honeycombs, and I found one that did the job on Thingiverse, and it was kind of neat because I opened it up and he had like 10, 20 lines of code of like, here's how you do it, and it was like all the proper geometry and math to figure out the angles for hexagons and spacing and everything like that. And he had that all commented out, and in a comment that said, here's the easy way. He took a cylinder, said it can only have 6 polygons. You have a cylinder, cut it down to 6 polygons, and you've got an instant like hexagon. I was like, well, that's pretty genius. So so browse Thingiverse, see what's out there. I also can't recommend the OpenSCAD cheat sheet enough. It's real easy. I don't have it on here because it's super easy to remember. If you go to openscad.org/cheat sheet, you'll get a box filled with like all the different commands. It looks like a printable cheat sheet that you can keep by your side, and that's great. You can use it for that. But each one of those is a link, and you click on it, takes you right to the appropriate entry in their wiki for all the documentation and stuff. It's the best ways to browse their documentation. And I always have that open when I'm working on something because I'll inevitably forget something. I'm absent-minded like that. And that's pretty much what I have. That's how I use OpenSCAD and the tricks that I've learned to get useful objects out of it. I'm willing to take any questions, or you feel free to stalk me online. Like I said, I'm Joe. There's my email address if you have any questions that you think of later. There's my Twitter. I mean, I check it, but I don't tweet a lot. But if that's the way you prefer to reach out to me. Anyway. Anybody got any questions or anything? I see I bored some people asleep. That's fine. It's dull. Yes. You.
This week is the 135th anniversary of William Rowan Hamilton writing the fundamental equations for quaternions on a bridge in Dublin. Do you get to use quaternions when you're doing your rotations?
You know way more about that. All right, so the question was, I don't even know how to pronounce that. Like, quaternions? Klingons?
Quaternion.
He knows a lot more about math and geometry than I do.
Okay. When you had a rotation function, it took a vector with 3 elements. Those
Yeah.
are called Euclidean rotations, where it's the rotation around the x, the y, and the z. It probably converts it into quaternions internally, but I was wondering if you saw that.
Yeah, that's probably a question for the developers.
Okay.
But yeah, I wish I
When
knew.
you
If
talk
you find
about-
out, let me know.
When you
'cause
talk
I-
about the fun of relearning your high school trigonometry and stuff,
Yeah. Well, and right there, I just learned something new.
Yeah.
Even though I'm the one up here supposed to like knowing everything. Yeah, he was next.
Whenever
door.
you did the hexagonal grid, doesn't that also apply? You could have 3-sided grid, 5-sided, just by modifying the script?
The which grid were we talking about?
If you turned the cylinder into a 6-sided cylinder
Yeah.
and then made an infinite grid of it, couldn't you also make a 3-sided lattice of 3-sided, or lattice of 4-sided, lattice of 5-sided, lattice of 7-sided, etc.?
Oh, you mean instead of like a 6-sided cylinder,
Yeah.
yeah, you just changing that $FN value, it defines the minimum number of polygons that you're supposed to use. So if I say 6, okay, it's 6, and yeah, you're absolutely right. That would work with anything. Yes.
If you were to use 2 polygons, do you think it could create an impossible shape?
Good question.
If I use 2 polygons to create an impossible shape,
In a 3-dimensional universe?
I don't know, it's computer.
I'm not 100% sure, but I'm probably going to I'm going to lean towards no, just because OpenSCAD, like I said, is intentionally designed so that you don't get those kind of funky things, like impossible objects like that. Once it renders it, it fills in like I said, it tries to make it watertight so you don't have anything impossible that you won't be able to export and use on a 3D printer. OpenSCAD was designed with that in mind. But I don't know that for sure. Try it. Yeah.
Can this be used to generate models for Second Life and virtual realities?
So you can export. I don't know what they would take. You can export things as an STL, a DXF, SVG, or like JPEG. There's a couple of others, but like any kind of like common,
formats.
a lot of everything that's pretty much common
Okay.
that people would encounter. I'd have to look specifically. I don't know what Second Life and them use, but maybe. Yes, sir.
Just a comment, just keep in mind everything is unitless. So when you design your object in OpenSCAD, you're not talking inches, millimeters, or miles. It could be, light years. It's whatever your printer.
Yeah, that's an excellent point. Everything in OpenSCAD is unitless, even though I had figures there. They're just abstract. It doesn't actually get any kind of defined value until you're actually trying to print it out. Most of the time you're using millimeters when you're dealing with 3D printers, but if you decide to use inches or anything, whatever you've tweaked your slicer to, that's what it'll interpret it as. But as far as OpenSCAD is concerned, yeah, it's a unitless measurement. Any other questions? Yeah.
I do have a question for you. One of the pains in the butt with OpenSCAD is trying to read that ridiculous little ruler that they include on the screen.
Yes, it is.
What a pain. Is there a dimensioning function?
No, there's not a dimension. So if you've used OpenSCAD and trying to use the on-screen rulers to figure out how big something is a chore. Your best bet is like if you're right up the edge and you zoom in, it ends up like not disappearing the ruler. So you got to like move things over just like a nudge a little bit, and then you can zoom in and get like finer detail. But it's a pain in the ass to get any kind of measurements. But yeah, there's no function in OpenSCAD to say how, here's an object, tell me that I've imported, tell me how long it is or how wide it is or anything like that. Because I think the thought process behind the developers at OpenSCAD, they're like, well, you're using OpenSCAD to create stuff. You should know how how big you're making it.
Yeah, but when you use the McKinsey
Right.
or however you pronounce it, whatever the measurements you have for that, like I use it to round my corner, so I use
Right.
.1. You have to add that or subtract that from your overall length. because-
Exactly, yeah, that's why I was saying you gotta take into account the radius of your bevels,
Yep.
like that.
And that's what happens if you've got a unit of one, you want to do them at Pinsky. Keep in mind, it's going to go all the way around it, so you got to subtract it.
Right.
Dot one
So if
here,
you, like,
dot
if
one
you add a 1-unit sphere to an object, your object actually gets bigger by 2 because it does it one on one side and one on the other. So you got to remember all that. And yeah, if you're importing in an object that you didn't design, like an STL or something, you're really kind of SOL. You don't know what that's going to, there's no way to figure out those dimensions. I've actually, and a couple other people have done it. I've made like a virtual ruler that I can pull up in there and reference
At
that.
the same time.
I put it alongside whatever object.
You can try it, yeah.
Yeah, that's clever. Okay.
Yeah.
What I do is, if I'm designing a case where it's going to have a top and a bottom, I do all of it at once, and then I can look through it, make sure my screw holes line up, my notches line up, and then when I'm done, I just separate that into 2 files, because I'm going to print them out one at a time, so that the bottom.
Right. Generally, what I do is like, yeah, I'll keep them all in one file, and then, like with the basically like with the robot head, I had everything in one giant library. Well, 2 or 3 libraries, like one for the neck, one for the jaw, and all the major pieces. And then I would have other functions where I'd import that as a library, and then say, okay, I just want the top jaw, and it would just render that for me. And that was just the way I decided to organize it at the time. I thought I was being smart. I don't know if that's the proper way to do it, but it's the way I did it.
I like it because then you can look at your pieces, and if you see any really vast discrepancies, you know that your math is off somewhere.
Right.
Yeah. So it's just a sanity check. If you got 2 pieces that got to fit, well, if they don't fit on the screen, they aren't going to fit on the print.
Yeah, you're right. Any other questions? You got one? Is your hand up? No? Okay. Any other questions? All right. Well, thank you. I hope you found this useful. Thank you very much.